Welcome back on the Space Info YouTube channel. It's Tom speaking, and today we'll talk about the International Space Station. Before starting, don't forget to subscribe to this channel and activate the notification bell. It's free for you, but it means a lot for us. We want to say thank you to everyone who commented our latest video. Those comments were much appreciated and help us a lot improving our work. Now, let's start. Even though it will no longer be the outermost base camp for Earthlings in a few years, today it remains the ultimate example of human strength and reciprocal commitment towards a common goal, the human presence outside our cradle. We all hope that in a few years in the future the Lunar Gateway and base camps will be a reality, as well as a colony on Mars, but if they will be ever come true. The ISS will still be a fundamental step in space travel, maybe with a strong contribution by the private industry. Soaring Earth at an approximate altitude of 400 kilometers from the surface, the International Space Station is a system built from 17 different blocks, the modules. Almost all of them have been built by one or more of the major space agencies in the world, among which they represent the USA, Europe, Russia, Japan and Canada. They then assigned each project to subcontractors, which are industries belonging to each of the previous nations. For this reason, the International Space Station does not belong to any of those countries in particular, but is a reciprocal collaboration. We know, what are you thinking about, Russia and the USA? Is this happening now? Well, it has been happening for more than 20 years. The recent tension between those two countries after the Russian invasion of Ukraine was of no help in this project, as Russia has more than once threatened to separate their modules from the others. But in practice this cannot happen without the loss of control from both the parts. If you remember, we already talked a little about the need of USA for the Russian Soyuz to let their astronauts fly until the Dragon capsule was fully certified by SpaceX to reconnect America and the West with the International Space Station. But we will talk more about this topic in the future. Stay tuned. How can the station orbit our planet? Even though Earth is quite a big body, ISS accomplishes 16 orbits per day, about 90 minutes each, which means it travels at an approximate speed of 28,000 kilometers per hour. But now stop for a minute. 16 orbits per day, 90 minutes each, 400 kilometers from the surface. Docking maneuvers, debris. Things have to be placed in space. What do we use? Rockets. And do you know how a rocket is made? If you are a young space enthusiast on the step towards his or her college studies, ready to walk the engineering path, or if you have worked for years in a completely different field, but you have a strong passion for space and rockets, we have something for you. Our introductory course on rocketry is now available with limited slots. Visit the link in the description below and our website for all the details, information and enrollment. Should you visit that link too late and find enrollment closed, don't worry. Join the members club on our website for free and you'll be the first to know when enrollment will be open again. Now back to the video. Often we joke about the two ways we can use to explain the motion of an orbiting body around another. Usually mathematicians like to say that the space station is falling towards our planet, which however moves constantly away, making the station fall towards its new position, and so on. Engineers like to look at it in the other way. Imagine that you were able to shoot a cannonball perfectly horizontally. At the first time you shoot with some power, but instantly that ball draws a parabola towards the ground and finishes its motion. If you add some power to the shot, the ball will draw a more stretched parabola, but the final result will be again a crash into ground. Now imagine that Earth had no mountains and was perfectly flat. You flat earthers, just an hypothesis. If your shot has enough power, the cannonball would travel so far, and fast, that would circumnavigate our planet in a circular orbit until passing over the starting point, and then again another orbit. This is basically what happens with all the orbiting bodies around our planet. They firstly need to climb into altitude thanks to rockets, but then, those same launchers turn horizontally to give more and more energy to the bodies they are placing into orbit, like that cannonball. Depending on the altitude of the orbit, the speed needed changes, but now you know that if you want to fly at 400 kilometers you need to be quite fast. Often we see astronauts floating inside the station, like there was no gravity. Actually, that is not much accurate. Gravity does not magically disappear. Indeed, its intensity is only 10% lower than on the surface of Earth. Think about how a body can stay in orbit. We discussed before. Thanks to its speed, it gains a centrifugal acceleration which would make it escape from Earth, which, thanks to its gravitational attraction, brings that body bonded to it, with a net balance of forces equal to 0. If you put some astronauts inside the space station, they will be subjected to the same physical environments, with the same balance of forces. For this reason, their relative motion with respect to the station will make them appear floating. Is there a place on Earth where you find microgravity conditions like these, 24 hours a day, every day? No, there is not. That is the reason, in brief, why we need an orbiting laboratory. But what kind of experiments are done and how is this laboratory kept into its orbit? When astronauts take part to long-duration mission, such as 6 months, their bones and muscles deteriorate at a much higher rate than here on Earth, and scientists can study the process to help people with tissues disease to improve their condition or even prevent it. Today, astronauts have to train more than 2 hours per day to counteract this aging process and be ready when they come back on Earth. But sick people may not be able to train like this. That's why the studies on those processes are so important and contribute to the life quality here on Earth. Besides to experiments on humans, also material science, geology, physics and botany. As an example, hydroponics was developed in space to help plants grow out of soil, with nutrients being given directly into a water solution, saving space and water, both becoming more and more precious resources here on the planet. Let's now talk about how the ISS is kept on track, avoiding it to fall back. Once rockets give the big push to escape Earth's gravity, most of the job is usually done. However, due to perturbations or specific needs, such as avoiding space debris, sometimes the station needs a smaller push to alter its altitude by some meters. Even though it is equipped with a number of solar panels, no electrical or ionic propulsion is yet used on board. There are 2 ways, a gyroscopic and a propulsive one. The first is exploited thanks to wheels strategically placed on the station which rotate at relatively high speed, generating a gyroscopic momentum which tends to maintain the whole system in its initial condition. But there is a problem. Sometimes the station has to react to external causes, so the rotational speed of these wheels is changed, until it reaches a maximum and they saturate. They can no more be effective. In order to reset their initial state, or when a bigger motion is required, small rockets are the answer. There is always at least a spacecraft which is docked to the station, being it a cargo, a Soyuz or a Dragon. From ground control, they coordinate the needed rocket ignitions in order to move the whole space station into the desired orbital slot. That's all for today. We hope you enjoyed knowing a bit more about this amazing spacecraft orbiting our planet 16 times a day. Stay tuned because more videos will come.